Hello everyone and welcome to a new video. In today's video I want to share the king of useless machines. I'm talking about a solution to Peterjiang's corner block challenge. If you don't know what this challenge is, the objective basically is to remove a corner block of a cube when the redstone to do this is inside the same very cube. Here you can see how I managed to complete this challenge. And as you can see, it successfully removes the corner block, and if I press the button again, it will just place back the corner block. I will now try to explain how this machine works. It is, as you can see, it is quite a complicated mess, but I'll try to do my best to explain it to a point where everyone can understand it. The machine also uses various extremely interesting techniques, so I'll definitely suggest to just stick around to the end. Let's first watch the machine in action again, but this time pay attention to the piston layout. Obviously you can't just grab the diamond block immediately. You first have to create space to reach the diamond block. This is what happens in the start, and in total 6 blocks will be removed. That are the 4 blocks in front here that are already dragged into the machine and the 2 blocks on top. I decided to store those 6 blocks in total far away down here at the bottom, because if I would store them very close to this area, they will just always be in the way and it would be very annoying to fit everything in. Then, to grab the 2 blocks at the bottom and eventually the diamond block, you need to bring in some additional pistons. Those pistons also need to be stored somewhere. However, I didn't want to store them with the rest of the blocks and instead stored them at the side of the block conveyor. Like you can see right here. They get pulled to the side of the conveyor. Then when the conveyor is empty, you can transport these 2 blocks all the way down to the block storage. Then when the blocks are in the block storage, some more observers and pistons are entered into the piston feed tape, and these will be used to grab the diamond blocks. As you can see, everything is moved into position. Then we jiggle around these observers a little bit to make sure that all the pistons are extended a proper number of times. So basically they just leave the blocks or the pistons in the correct spot. Then we will basically put or pull everything down the conveyor again and store it to the side. Just like this. Now there is space to move the diamond block down again, and then we can start by closing these 6 blocks in again. Getting those 6 blocks in place is actually a very similar procedure, so I'll just speed up the game a bit. I won't show how to put this block back, as it basically is just the same sequence except a few tiny steps are switched around. Now let's take a look at how I actually wired up this machine. So you could see that this entire sequence was quite long. I mean, in total there happened around 180 different actions. With normal piston doors you kind of hardwire or hard code these actions with redstone. However, a sequence of 180 actions is long, even for piston doors. On top of that, there only are 9 different actions that need to happen. And these actions need to happen in a quite particular but also quite random seemingly order. So for example, you just activate the conveyor 9 times, then you activate these pistons here in a quite random order, then you activate the conveyor 8 times again. There's really no easy way to wire this up with redstone. So whenever I run into like a lot of complicated problems like these timings issues, I try to generalize the problem and try to find a solution that fixes all the problems in one go. In this case, that was making use of a memory system. To make use of a memory system, I first had to get all the inputs in a row next to each other. That is what you can see right here. Each of these observer lines activate a particular action. For example, this row will retract these or activate these 4 pistons. This observer will activate these 2 pistons. Now to remove and place the block back, I only have to activate all these inputs in the correct order. And this is where the memory system comes into play. This here is the memory system. It consists out of 2 piston feed tapes with minecarts inside them. The piston tape on the right is used to get rid of the diamond block, and the tape on the left here is used to place the diamond block back. Each minecart is filled with shulker boxes, and these shulker boxes are color coded. Each color corresponds with a certain number of items in them. Each shulker box is dragged out of this minecart one at a time and will go to this dispenser. This dispenser then will dispense the shulker box, and this comparator can read the signal strength. And obviously, since each color has a specific number of items in them, each color of shulker box will also give a different signal strength. The shulker boxes are then broken and put back into an empty minecart that is in this position here. What is very important here is that the order of the shulker boxes remains the same. Then when this shulker box is empty, or when this minecart is empty, it will rotate the piston feed tape, and now the empty minecart is placed here, and shulker boxes from this minecart can flow in the empty minecart. Now let's go back to the place where the shulker boxes are dispensed. This comparator takes the output of the shulker boxes and sends this down this wire here. This output will go into this signal strength decoder. This decodes the signal and sends it in this very specific order into the different inputs for the actions. And this is how I encoded the specific sequence of 180 actions long into this very small and simple piston feed tape. And this is how this door actually knows how to retract the diamond block. I hope that this explanation made sense and that you can somehow follow what is going on here even without understanding the redstone. And if you have any questions, you can obviously ask them to me in the comment section. Then I want to give credits to Narcoleptic Frog. He was the first one that I had seen to use like a rotating minecart with chest system for memory. And I kind of took his setup and improved it a little bit by using more minecarts. And I also used shulker boxes inside these minecarts instead of just normal non-stackable and stackable items. Because I did not just need 2 inputs, but I actually have 9 different inputs. Which just means that 2 different types, the non-stackable and the stackable items, are not gonna cut it. Then I obviously also want to thank Peterjiang for this challenge. I had a really good time working on this, and you can obviously find a link to both these people in the description. Now let's end the video by watching this block being put back and retracted one last time.